Welcome back everyone. I hope you're doing great. Mandar Chakrabarti here. In the last video, we just started our discussion on the concepts of electromagnetic waves and how much we utilize electromagnetic waves in our daily lives without even realizing it. To substantiate this claim, we had a discussion on some of the different everyday technologies which depend on the manipulation of electromagnetic waves. We discussed how a simple mobile phone conversation has such a complicated underlying technology. In this video, I would like to continue on this trend and I would like to introduce you to the electromagnetic spectrum. So let's get started, shall we? If I were to summarize the electromagnetic spectrum, then basically it encompasses the entire range of frequencies in the natural physical world, and it looks something like this. It starts from the tremendously low frequency, or TLF as it is more commonly known as, which is all the way on that side, which is basically another name for all forms of natural and artificial electromagnetic noise, all the way up to this side, which is the zeta hertz frequency, where cosmic rays and gamma rays abound. Now, if you look into this image, you will find that the visible spectrum, let me point that out for you, it's right about here or here. So the visible spectrum, or the range of frequencies that our eyes can perceive, consists of a very tiny fraction of the entire electromagnetic spectrum. So which is basically to say that we are so very blind when it comes to the natural electromagnetic spectrum all around us. See what I did there? Anyway, jokes aside, now the electromagnetic spectrum is broadly split into two components which are shown in this lower diagram over here. So you see the lower half of the frequencies, so at this portion, all the way up to a range of around 300 gigahertz is known as the radio spectrum. The higher half of it, which goes all the way up to the lower exahertz region, is known as the optical region. Now, if you look a little bit more closely at the radio spectrum, you will find that there are further subdivisions in the form of low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency, and extremely high frequency. Believe me, I am not making up these names. These are standardized names. You see, these frequency ranges are utilized in various formats in wireless radio communications. Similarly, in the optical spectrum, there are further subdivisions in the form of infrared spectrum, visible spectrum, optical spectrum, X-rays, gamma rays, and of course, cosmic rays. These two find applications not just in communication systems, but also in the medical field as well. I'm sure that everyone knows that an X-ray is something that all of us need to get if we meet with some form of an accident and end up with maybe broken bones. In fact, infrared technology provides us with a very cheap form of communication, and I'm pretty sure once again that every one of us has utilized infrared communication without even realizing the system that we are utilizing. I would like you to look now towards me. You see, in my hand, I am holding an ordinary remote control. Now, if I press any button on this remote control, you can see that there is a tiny little light which is flickering. But if you were to take a remote control similar to this and look at it with your own eyes, you will not be able to see this sort of a light. This is because this remote control utilizes infrared light to transmit the signals from the remote to the receiver on the device. And of course, infrared is not something that our human eyes can see. So then the question becomes, how exactly am I able to see this light through this camera? Well, you see, a digital camera is able to pick up a slightly wider spectrum of light than just the visible spectrum. There is a digital signal processor inside every digital camera which converts this spectrum of light into digital information. And it is this digital information which again gets converted back into images that we are seeing on the screen of this computer. Now, what actually happens inside this particular digital signal processor is that the high infrared and on the other side the low infrared frequencies gets slightly compressed and converted into a digital signal that sort of represents red light and violet light. That is the reason why, if you look at these devices only through a digital camera, only then are you able to visualize infrared light with our own naked eyes. Now let me look at something else. Let us consider how the electromagnetic spectrum interacts with the atmosphere of our Earth. You see, the image over here shows the portions of the electromagnetic spectrum which are actually able to pass through the Earth's atmosphere. The brown portions mark the range of frequencies which are not able to pass through the Earth's atmosphere. So you can see, these frequencies are blocked by the Earth's atmosphere. Now, gamma rays, X-rays and ultraviolet light, which are all generated by our sun, are blocked out by the Earth's atmosphere. And it's a very good thing that it happens in this particular way. Because if we humans were actually exposed to gamma rays, X-rays and ultraviolet rays, then we would end up with terrible forms of disease. Now, the visible spectrum is of course observable from the surface of the Earth with a slight amount of atmospheric distortion. Now you see, there are another range of frequencies which are able to pass through the Earth's atmosphere. These frequencies are known as microwave frequencies. Microwave frequencies are utilized extensively in wireless communication that we were speaking about in the earlier video. The uplinking and downlinking of signals to and from satellites and vice versa. You see, the longer wavelength signals or low frequency signals which contribute to radio waves are again blocked out by the Earth's atmosphere. This effect is again utilized very cleverly by our communication devices for a different form of terrestrial communication. Now this next image, it gives us greater details about all the different applications which are possible by the manipulation of electromagnetic spectrum. So you can see the AM radio, FM radio, they all function in the radio spectrum. Our mobile phones also function in the radio spectrum. Ultrasound, which is utilized for medical applications, also function in this low frequency radio frequency range known as the radio spectrum. Our television broadcast, the Wi-Fi signals, even the microwave oven that we use to cook our food all function in this low frequency radio spectrum. Radar systems which are utilized by air traffic control and also by the military also function in this radio spectrum range. Now there is a very small range of frequencies which is known as the terahertz frequencies, where electronic devices gradually merge with optical devices. Now, the terahertz frequency range is extensively being researched upon currently. Applications such as bioimaging for the early detection of cancer cells, or even the very advanced form of human screening which is utilized in airports, all utilize terahertz frequency range. The next one, fiber optic communication, something that we were referring to in the earlier video, relies heavily on infrared frequency range. In fact, your fiber optic communication network forms the backbone of the modern communication system of the entire world. There are literally hundreds of thousands of miles of fiber optic cables which are laid underneath the oceans, such as the transatlantic cables, which carry huge amounts of data across one continent to another at unimaginable speeds. Then of course there are your medical x-rays and baggage screening devices at the airports which rely on the x-ray frequency range. Going into the gamma frequency range, PET imaging devices which are used in advanced medical diagnosis relies on gamma frequencies for its functioning. Now, this table illustrates some more applications of the electromagnetic frequencies of the frequencies of the electromagnetic spectrum. Feel free to pause the video at this point if you want to take a closer look at these different applications and the different frequency ranges. Now, moving on to a little bit of history. We have already stated that wireless technology is not something new. Wireless technology has been around for close to 200 years now, or even longer. But over the ages, there have been many scientists who have contributed to the development of wireless technology. But these 11 scientists, these 11 gentlemen, they have laid the greatest contribution to this particular field. And it should be a matter of immense pride for us Bengalis to see the name of our very own Bengali, Acharya Jagadish Chandra Bose, on this list. You see, J.C. Bose was one of the pioneers in this field of wireless technology. He was one of the first people to demonstrate physically the utility of wireless technology through practical implementations. In the year 1884, Jagadish Chandra Bose, through a public demonstration in the town hall of Calcutta, ignited some gunpowder and rang a bell at a distance using millimeter wave frequencies by using his own invention. Now, it is a matter of some controversy in the scientific world that the Italian scientist Guglielmo Marconi is credited with the first wireless signal transmission, where in fact that credit rightly should belong to Acharya Jagadish Chandra Bose. But it's a controversial topic and we do not want to go into that. In this subject, however, we are going to be dealing extensively with the contributions of this gentleman on this corner of the screen, Mr. James Clerk Maxwell. You see, basically, the hypotheses which were formulated by Coulomb, Gauss, Ørsted, Faraday, Ampere all pertain to different distinct fields in the area of electromagnetic theory, and at the time of their conception they were not thought to interconnect with each other. But it was James Clerk Maxwell who first managed to understand that these different hypotheses are all actually interlinked with each other, and he formulated the now famous Maxwell's laws. Remember, we studied these Maxwell laws in the earlier one. These Maxwell's laws combine electrostatics and magnetostatics into one unified electromagnetic theory. And it is the application of this unified electromagnetic field theory that has given rise to all these different devices that we now rely on a daily basis. If you are interested in a more detailed study of the birth of wireless technology, then I would suggest that you pause the video on this particular slide and go through this slide, which details the timelines of development and formulation of the various laws pertaining to the world of electromagnetic field theory. I hope that I have been able to convince you of the extreme depth of the applications of electromagnetic theory in our modern life and how it is spread to almost every branch of our modern day survival. Thank you so much for watching. I really hope that you got something useful out of this video. I would like for you to let me know in the comments below which of these different technologies did you find to be the most astounding. If you enjoyed this content, then a sub to the channel would be really helpful. I plan on continuing this tutorial series on a regular basis to help out my students with their curriculum. Okay, so that's it for today. I'll see you in the next one. Bye bye.